Hello everyone. So we are going to start the part 11 of the chapter for this person. So in this particular unit, in this particular presentation, we are going to discuss regarding some of the stability issue that is very common which we used to face by preparation of the emulsion. This stability issue actually when they get deformed, then this emulsion, whichever it has formed, it leads to the instability. So without wasting any time, let's start our presentation. So number one issue, it is the flocculation. So as we have already discussed, what is a flocculation? See, the neighboring globules which are dispersed in the dispersion medium, when they come close to each other, they generally form colonies. You see, they generally form colonies. They get bind to one another, right? So this aggregation of the globule, it is not clearly visible, but when the globule come close to one another, they generally forms this colony, right? Now this is the initial step, and this lead to the instability of the emulsion. So the flocculation of the dispersed phase, it takes place sometime before the mixing, or sometime during the mixing, or after the cleaning. The flocculation takes place. So the reversibility of the flocculation, reversibility means whenever the flocculation or the process of flocculation can be reversed. Means suppose the flocculation has taken place now in the bottle of the emulsion. Now if we resuspense or if we hesitate the bottle, then the flocculation or the dispersed phase will get separated from each other, right? So the reversibility of the flocculation, it depends totally upon the strength of interaction between the particle. Now the strength of interaction between the particle, it is determined by three different attributes. They are: number one, the chemical nature of the emulsifier, which type of emulsifier we have used, number one. Number two, it is the phase volume ratio. Now what is phase volume ratio? Phase volume ratio means the ratio of the two phases, the ratio of the oil phase or the volume of the oil phase divided by the volume of the water phase, or you can say the volume of the dispersed phase divided by the volume of the dispersion medium. And the third condition on which the flocculation determines, the reversibility determines, it is the concentration of the dissolved substances, especially the electrolytes and the ionic emulsifier in the emulsion. So these are the three factors which actually determine how the flocculation, or how the flocculation can be reversed, or how we are going to get it back, right? So now the extent of flocculation of the globules, it depends upon extent of flocculation. It depends upon three things. Number one, it is the globule size distribution. So how the globular size distribution has taken place means some globules may attain, suppose, a size of 100 nanometer, some are attaining a size of 150, some are attaining a size of 200, some are attaining a size of 1000 nanometer. So in this way, this is expressed as a globular size distribution. So the extent of the flocculation, it totally depends upon the globule size distribution, how the size it is distributed. Number two, it is the charge on the globule surface. So what is the charge that is present on the surface of the globule? That is the dispersed phase. And number three, it is the viscosity of the external medium. It depends, these three factors, they actually controls the rate of flocculation. So number one, let's discuss globule size distribution. So how you can control the globule size distribution? Simple. The thing is that uniform size globules, it prevent the flocculation. Uniform size globules means the same size globules, it prevent the flocculation, and this can be achieved by proper size reduction process. The globule size distribution can be achieved by proper size reduction process. Means if we perform the proper size reduction, then all the globule size will come close to one another, means they will have a uniform size distribution. Next thing, it is a charge on the globule surface. So charge on the globule surface actually exert repulsive forces with the neighboring molecule, right? So how we can get a good charge on the globule surface? This can be achieved by using ionic emulsifying agent, for example electrolytes, right? And the last one, that is the viscosity of the external medium. If the viscosity of the external medium is increased, the globule become relatively immobile and the flocculation can be prevented. The next thing is that, you see, the viscosity, how you are going to attain that viscosity? That this viscosity can be attained by adding viscosity improving agent, like the viscosity modifying agent. So this includes the bonding agent or the thickening agent such as hydrocolloids and waxes can be used. Moreover, the flocks, they slowly move either upward. After a formation, they slowly move either upward or downward, leading to the creaming. The flocculation, it leads to the creaming. So the flocculation, it is due to the interaction of the attractive and repulsive forces, whereas the creaming, it is due to the difference in the density between the two phases. You should remember one thing, that flocculation, it occurs due to the interaction of the attractive and repulsive forces, whereas the creaming, after the flocculation, the creaming occurs. So the creaming, it solely depends upon the difference in the densities between the two phases. Done. So creaming. So the creaming, it is defined as the upward movement of the dispersed droplets of the emulsion. Upward movement means the emulsion, the dispersed phase will move upward at the top, right, relative to the continuous phase, and it occurs mainly due to the density differences between the two phases, right? So the creaming, it is the concentration of the globules at the top or the bottom of the emulsion. Creaming, it is the concentration, means the globules will either move upward at the top surface or it will move downward at the bottom surface. Done. So the droplets larger than 1 millimeter, they may settle preferentially to the top or the bottom under the gravitational force. I repeat, the droplets larger than 1 millimeter in size, they may either settle preferentially at the top of the emulsion or they may settle at the bottom of the emulsion, which is based on the gravitational forces. So the creaming may be also observed on account of the difference in the individual globules. So movements rather than the flocks. I repeat, the creaming may also be observed on account of the difference of individual globules. Clear? So it can be observed by difference in the color shade of the layers which has formed in the emulsion after storing for a long while. So this is a reversible process. This creaming, this is a reversible process, as because if the cream has produced, this cream can be redispersed very easily by agitation. By simple shaking, it can be redispersed, and this process is possible because the oil globules are still surrounded by the protective sheet of the emulsifier. As the creaming, in the creaming, what happens, the oil globules, it may either go to the top or it may settle down at the bottom, but these globules can be resuspended by simple agitation, as because in the creaming also the dispersed phase or the dispersed globules, they contain a surface or protective layer over their surface. Then so this creaming, actually it results in the lack of uniformity of the drug distribution, obviously, because if it is the creaming and this is the sedimentation, right? If it happens, all the drug molecule will be here at the top and the remaining will be free, and similarly if it happens, the drug molecule will be at the bottom and the upper one, it will be free. So if we don't do a proper agitation, and it will lead to the ununiform drug distribution. So this led to the actually variable dosage form. So therefore the emulsion should be shaken thoroughly before use. It is very similar to that of the suspension also. So the creaming is of two types, generally the upward creaming, this is the upward creaming, and the downward creaming, right? So the upward creaming, it is due to the upward creaming occurs due to the dispersed phase is less dense than the continuous phase. So when the dispersed phase it is less dense, it will float right at the top, and it is normally the creaming, it is normally observed in the oil in water type of emulsion, where the oil is less dense as compared to the water. The oil will come upward here and the water will remain behind. The velocity of the sedimentation here becomes negative, because sedimentation velocity is negative, because if sedimentation occurs, it should come downward, but here in the creaming it goes upward. As the velocity of the sedimentation here, it is negative. And the downward creaming, this is the downward creaming, it occurs if the dispersed phase is heavier, right? So it generally occurs in water in the oil type, and it occurs due to the gravitational force. Clear? Now, since the creaming, it involves the movement of the globules, so here also we can apply the Stokes law. So we have already discussed regarding the Stokes law in our colloidal chapter, in our suspension chapter. So as per the Stokes law, the rate of the creaming, it depends upon few factors. These are the creaming, it is influenced by the size of the globule, right? The viscosity of the dispersion medium and the difference in the density of the dispersion medium as well as the dispersion phase. So how the globule size is affect the creaming? You see, creaming can be reduced or prevented by reducing the particle size by homogenization. Means during the time of preparation of the emulsion, if we do the proper homogenization, the creaming can be reduced, because actually the homogenization, it helps in the proper dispersion of the dispersed phase in the dispersion medium. So if we double the diameter of the oil globule, it increases the rate of creaming by a factor of 4. This is simple. It has come from the Stokes law, right? The velocity, it is directly proportional to the diameter, right? Now the next thing, it is the increasing the viscosity of the external phase by adding thickening agents such as methyl cellulose and trigacant and sodium alginate. So if we increase the viscosity, then also the creaming will come down, and reducing the difference in the density between the dispersed phase and the dispersion medium. So the next concept now here, it is the coalescence. Now this coalescence, along with coalescence, we have two more component. It is the one, it is the aggregation, and the one, it is the breaking. So what is aggregation? Aggregation is nothing but the dispersed particles, they will come close, but in the aggregation they never diffuse to form a bigger droplet. In the aggregation, the particles, they will come close, but they never diffuse. In the coalescence, it is a process by which the emulsified particles merge with each other to form a large particles. In the coalescence, the particles will merge. They will merge with one another. They will get mixed up with one another to form a large particle. So this type of close packing induces actually greater cohesion, which lead to the coalescence. So in this process, actually in the coalescence process, the emulsifier film, which is present around the globule. In the coalescence process, the emulsifying film or emulsifier film, which is present around the globule, it get destroyed up to some extent. And when this emulsifying film or emulsifier film, it get destroyed, it led to the what? Coalescence, means fusion of the two particles, and this process can be recognized by increasing the globule size and reduce number of the globules. So the coalescence is observed due to three factors. Number one, insufficient amount of the emulsifying agent. If we use insufficient amount of the emulsifying agent, this can lead to the coalescence, that is the fusion of the dispersed phase. Next, altered partitioning of the emulsifying agent. Now what is altered partitioning? Suppose we have used an emulsifying agent which is supposed to be in the oil phase. Now it has gone to the water phase in a more amount. Partitioning difference means the amount or the concentration of the emulsifying agent in the oil phase and the concentration of the emulsifying agent in the water phase. If the partitioning, if the distribution of the emulsifying agent in water and oil phase, it gets disturbed, this can lead to coalescence. And last one, it is the incompatibilities between the emulsifying agent. So the phase volume ratio of an emulsifying agent or the phase volume ratio of an emulsion. Phase volume ratio means the volume of the dispersed phase divided by the volume of the dispersion medium. So if the phase volume ratio of an emulsifying agent, it has a secondary influence on the stability of the product, and actually it relatively represents the relative volume of the water to the oil in an emulsion. Clear? So the major factor which can prevent the coalescence, it is the mechanical strength of the interfacial film. Now what is the mechanical strength of the interfacial film? It is the strength of the emulsifying film which has formed over the dispersed phase. Now the next part, it is the breaking. You can see here directly how it has break, oil and water, how it has break. So breaking means it is the destroying of the film surrounding the particles. Which film? It is the destruction of the emulsifier film which has formed around the dispersed phase. So this led to the separation of the internal phase from the external phase, and this can lead to the breaking of the emulsion. So it is indicated in the breaking. Actually you can see it by naked eyes because it is indicated by complete separation of the oil and aqueous phases, and the breaking, it is a irreversible process. So simple mixing, actually it fails here, and it is to resuspend the globule into the uniform emulsion. So it is very hard here. After the breaking, it is very hard to resuspend the oil phase in the water phase. So in the breaking, actually, the protective sheet around the globules is completely destroyed, and the oil it tends to coalescence, and it forms a separate layer from each other, right? The next instability issue, it is the phase inversion. Phase inversion, as I have already told you, the water in oil type of emulsion may get converted into oil in water type of emulsion. So this involves the change in the emulsion type from water in oil to oil in water, or vice versa, right? So suppose we want to prepare an emulsion, suppose oil in water type of emulsion, but after preparing the emulsion, we have get it water in oil type of emulsion, then this can be sign of an instability, and this is generally known as the phase inversion. So why phase inversion takes place? You see, the emulsion type, it is determined by the oil to water ratio. It is the amount, that is the phase volume. So the solubility, moreover the solubility of the emulsifying agent. As I have already told you, the partitioning behavior of the emulsifying agent. So phase inversion, actually it is the change in the type of emulsion. Either water to oil will get converted into oil to water, or oil to water will get converted into water to oil. So the thing is that here you see, this is a very important concept. So the most stable range of the dispersed phase, stable range of the dispersed phase in an emulsion is generally, we consider 30 to 60%. If an emulsion have 30 to 60% of the dispersed phase, then we consider it as a stable. But if the amount of the dispersed phase it exceed a theoretical value of suppose 74%, suppose 74% of the dispersed phase it has become either oil or water, then immediately the type of emulsion will change. So 74%, it is the theoretical threshold value. If we extend, then the type of emulsion it gets changes. So addition of substances which alter the solubility of the emulsifying agent may also causes the phase inversion. Thus, if we add any substance in the emulsion, if that affect the solubility of the emulsifying agent, it can cause the phase inversion. And this phase inversion process, it is a very permanent process. We cannot reverse it back. Clear? So thank you everyone for your patience hearing. If you like the video, just press the like icon. You can share this video, and you can subscribe to my channel. Thank you once again.